Ever heard the saying, it's like reinventing the wheel? Well, get ready because today, that's exactly what we're not doing.
Okay, I like where this is going.
We're diving deep into a treasure trove of your excerpts about the greatest inventions ever. But here's the twist. We're not just listing them. We're on a quest to uncover those hidden connections.
The aha moments where one brilliant spark ignited another, sometimes centuries apart.
You got it. It's going to be a wild ride through history.
I'm buckled up and ready. Let's roll.
So, to kick things off, we've got to start with the one that literally set everything in motion, the wheel. It seems so basic now,
But think about it. Around 3000 BC in Mesopotamia, this thing was revolutionary.
And not just for getting around, I was surprised to learn how much it impacted, of all things, agriculture.
Right. Imagine grinding grain by hand all day, every day. Brutal.
Yeah, no thanks.
But then boom, the wheel. Suddenly you have watermills and windmills harnessing nature's power. Grinding grain becomes almost effortless.
Freeing up people to do, well, anything BUT grind green.
Exactly. Food surpluses, population growth, the rise of civilizations, all made possible by a simple wheel. It's mind-blowing.
It really highlights how a single invention can have this ripple effect, touching every corner of society.
And that ripple effect is something we'll see time and again as we go. But speaking of game changers, let's talk about another invention with serious power. The steam engine.
From what I read, it wasn't just some sudden eureka moment, right?
Not at all. It was a long and winding road. Way back in 100 AD, Hero of Alexandria, this Greek inventor, described something called the sphere of Aeolus, basically. A steam-powered spinning wheel.
Wait, the Greeks had steam power. What were they doing with it way back then?
To get this, they used it for entertainment. Can you imagine this incredible force of nature reduced to a toy for an emperor?
Talk about a missed opportunity. It makes you think about all the potential innovations that might have been overlooked throughout history.
It really highlights how an invention's impact isn't just about the tech itself. It's about the context, the society, the vision, or lack thereof. It took almost 2,000 years for someone to truly grasp steam's potential.
Yeah, and that someone was
Thomas Newcomen, around 1712. His atmospheric steam engine was a game changer.
But wasn't it James Watt who made the steam engine really famous?
He did. But Newcomen laid the groundwork. His engine was mainly used to pump water out of mines. Watt came along and saw a way to make it more efficient, more powerful.
And that, my friend, is how we got steamships crossing oceans and locomotives thundering across continents.
Exactly. Robert Fulton, this American guy in the early 1800s, he shows everyone what a steamboat can do with his ship, the Claremont.
And then there's the Transcontinental Railroad, connecting the east coast of America to the west, all thanks to steam. Talk about shrinking the world.
It's amazing to think about. You've got this ancient invention, the wheel, combined with this powerful new technology, steam, and suddenly the landscape of a nation is transformed.
And then, of course, the steam engine helped pave the way for something that would really change how we get around the automobile.
It's funny you mention that because one of our excerpts talks about Henry Ford, the guy who really made cars mainstream. When he was a kid, he had this life-changing encounter with a steam traction engine. Some people say that's what sparked his whole obsession with machines and mobility.
So the assembly line, the Model T, making cars affordable for everyday folks, it all traces back to this childhood fascination with steam. How about that? It's a classic example of how those early influences can have a huge impact.
Absolutely. But Ford also understood something crucial to change the world. Inventions need to be affordable and accessible to the average person.
Absolutely. But all those cars, all those machines, they needed a different kind of power. And that takes us to another electrifying chapter in our story, electricity. Where do we even begin?
Well, there's that classic tale of Ben Franklin, a kite, a key, and a thunderstorm, risking his life to understand electricity.
Talk about dedication. It's one of those stories everyone knows, but still, lightning is electricity. It just blows your mind.
It's a turning point. That spark of knowledge literally ignited so many other innovations, like the battery, for example. You think of batteries as pretty modern.
Besides that whole ancient battery thing. Yeah.
Right. But even beyond that, in the 1930s, this artifact was found in Baghdad, a clay pot with a copper tube and an iron rod sealed up.
And this was a battery.
Maybe. Some people think so. They called it the Baghdad battery. No one's 100% sure how it was used, or even if it really worked like a battery. But
it makes you wonder what else is out there buried in the past, waiting to be rediscovered. Like, were there ancient Mesopotamian iPhones we just don't know about?
Now, that would be a find. But while the Baghdad battery is still a bit of a mystery, There's no denying the impact of Alessandro Volta. His voltaic pile was a game changer.
Stacking those copper and zinc discs, creating the first true electric battery. So simple, yet so profound.
And this breakthrough paved the way for communication to break free from the limits of physical wires. It was the spark that ignited the invention of the telegraph.
From snail mail to almost instant communication, all thanks to electricity. And nobody grasped that power better than Samuel Morse. Dots and dashes, baby.
Morse code, the original digital language. That 1844 demonstration sending that message, what hath God wrought? From Washington, D.C. to Baltimore, it marked a new era.
It's amazing how quickly things took off after that. Within a couple of decades, there were undersea cables crossing the Atlantic, connecting continents through the power of electric signals. It would have blown people's minds back then.
It goes to show how powerful it is when an invention taps into a fundamental human need, in this case, our need to connect.
And that need just kept evolving. With the telegraph started, the telephone amplified in a whole new way. Alexander Graham Bell, a teacher of the deaf, dared to imagine hearing the human voice transmitted over wires.
Imagine that. The emotion, the laughter, the tears, suddenly, distance meant so much less.
It's wild to think that Western Union, the telegraph giant, they actually dismissed the telephone at first, called it a toy. Oops.
Talk about a failure of imagination. It makes you wonder, what are we overlooking today? What seems like a novelty now that in a few years will completely redefine our world.
Ooh, that's something to think about. But while we're on the topic of inventions that illuminate our world, literally this time, we got to talk about Thomas Edison and his incandescent light bulb.
Edison, the Wizard of Menlo Park. He didn't just invent the light bulb. He created an entire system.
Power generation, distribution, the works. He knew that an invention is only as good as its infrastructure.
Precisely. But it's amazing to think even he couldn't have predicted how much the light bulb would change things. Work, entertainment, advertising. It's more than just illumination. It's an entirely new way of life.
It's a perfect example of how one invention can spark so many others. Like in this case, while Edison was working on the light bulb, he stumbled upon something that would lead to electronics as we know them. The vacuum tube.
That's a story for another day.
Oh, you're killing me. All right, fine. We'll save the vacuum tube saga for next time. But listeners, trust me, it's a good one. Join us again as we continue this incredible deep dive into the history of invention. We've got way more aha moments to uncover.
So you're right, that vacuum tube story, it's a good one. It shows how Edison, in his quest to perfect the light bulb, stumbled upon this phenomena that would change electronics forever.
Okay, spill the tea. How does a light bulb lead to something as complex as a vacuum tube?
Picture Edison in his lab, surrounded by light bulbs. He's experimenting and notices something strange. When he puts a metal plate inside the bulb near the filament, a current starts flowing between them when the filament heats up.
Interesting, but I don't quite see the connection to, say, a radio or something.
Well, at the time, neither did Edison. He called it the Edison effect, but he didn't fully understand it. But it was an early observation of what we now call thermionic emission, the release of electrons from a heated material. See, vacuum tubes use this principle to control a flow of electricity, and they became essential for radios, televisions, all sorts of electronics.
So a light bulb experiment accidentally paved the way for the electronics age. Talk about a happy accident. But before we dive into all that, we were talking about another tiny invention with a huge impact: transistors.
Absolutely. But let's not forget the vacuum tube was king for a while. They were used in everything from radios to early computers. But those things were huge, unreliable, used a ton of power.
Yeah, not exactly pocket size.
Exactly. The transistor was a game changer, smaller, more reliable, and way more energy efficient. But like so many great inventions, the transistor was a team effort. John Bardeen, Walter Bratton, and William Shockley at Bell Labs, they cracked the code in the 1940s.
Bell Labs again. What was it about that place? Seems like they were behind so many breakthroughs.
Bell Labs was this incredible hub of innovation. They had brilliant minds from all different fields working together: physicists, chemists, engineers, a recipe for groundbreaking discoveries.
So how did they even come up with the transistor? What problem were they trying to solve?
Well, they were looking for a better way to control the flow of electricity in electronics. See, vacuum tubes were doing the job, but they were clunky and inefficient. Transistors offered a more elegant solution using semiconductors.
Semiconductors. Okay, break that down for me. What's so special about a semiconductor?
Think of it like this. You have conductors, which electricity flows through easily, like copper wires. And you have insulators, which block the flow of electricity, like rubber. Semiconductors are somewhere in between. They can act as both a conductor and an insulator, depending on certain conditions.
Gosh, I'm with you so far.
So what Bardeen, Bertin, and Shockley figured out was how to use these unique properties of semiconductors to create a tiny switch that could control the flow of electricity with incredible precision. They could amplify signals, turn them on and off, all using a fraction of the power of a vacuum tube.
So no more room-sized radios. That's what I call progress.
Right. Transistors shrunk electronics, made them more affordable, and opened up a whole world of possibilities. Think about it without transistors. No smartphones, no laptops, no digital revolution.
It's mind-boggling when you think about it. And the story doesn't stop there. We had the transistor, but then came the integrated circuit, the infamous chip.
Right. Imagine cramming thousands, then millions, now billions of transistors onto a tiny piece of silicon.
That is insane. It's like shrinking a supercomputer down to the size of your fingernail.
Exactly. And it all happened incredibly fast. Jack Kilby and Robert Noyce, they independently invented the integrated circuit in the late 1950s. This led to Moore's law, the observation that the number of transistors on a chip doubles roughly every 2 years. And that, my friend, has driven the digital revolution.
It's like a snowball effect of innovation. So we've gone from the wheel to steam power to electricity to the microchip, and it's all interconnected.
Absolutely. And these tiny chips now power everything around us.
We're living in the future. But for all the wonders of the digital world, some inventions have completely reshaped our understanding of health. And that brings us to the microscope. It's amazing to think that for centuries we had no idea this whole microscopic world even existed.
Right. Imagine thinking you understand how life works and then boom, the microscope comes along. Suddenly there's a whole universe of microorganisms living all around us, on us, inside us.
And not all of them friendly. I can't imagine what it must have been like back then, not knowing what caused diseases or how to treat them.
It was a different world. But then we get Anthony van Leeuwenhoek in the 17th century. He starts looking at stuff under his handmade microscopes, water, insects, even the plaque from his own teeth. And boom, he sees bacteria for the first time.
Talk about a paradigm shift.
It revolutionized medicine. Now we can actually see these tiny creatures that make us sick. It's what paved the way for understanding how diseases spread and, most importantly, how to fight back.
And that leads us to another incredible invention, vaccines. Arguably one of the most impactful inventions in human history.
Absolutely. Vaccines have saved countless lives. And it all started with a simple observation by Edward Jenner in the late 1700s. He noticed something interesting about milkmaids. The ones who got cowpox, which was mild, seemed to be immune to smallpox.
Smallpox, that's the one that used to be a global killer, right?
Exactly. So Jenner had this hunch, what if exposure to cowpox could protect against smallpox? It was a risky idea, but he tested it by inoculating a young boy with cowpox. And guess what? When he exposed the boy to smallpox later, the boy didn't get sick.
It's amazing to think that experiment was the spark for vaccines as we know them today.
It really was. But the story of vaccines doesn't end there. We have Louis Pasteur to thank for taking it even further. He developed vaccines for rabies, anthrax, and made huge contributions to the field of immunology. He helped us understand how vaccines work at a fundamental level.
It's amazing how much our understanding of the microscopic world has advanced, and those advancements led to life-saving medical interventions.
It's incredible to think about this whole other world, invisible to the naked eye, dictating our health. But there's another level to this microscopic story. Viruses.
Oh, right. Viruses even smaller than bacteria. Those things are weird, right? Somewhere between living and non-living.
Exactly. And for a long time, they were invisible to us. We couldn't see them with traditional microscopes. Then, in the 1930s, came the electron microscope.
Game changer. Suddenly, we could see viruses up close and personal, understand how they infect cells, how they replicate.
Think about it. Seeing something for the first time allows you to understand it, to target it, to develop treatments. That's exactly what happened with viruses.
The eradication of smallpox, vaccines for polio, measles, and countless other diseases, the electron microscope played a crucial role.
And its impact wasn't limited to medicine. Material science was also revolutionized. Suddenly, we could see the structure of metals, plastics, everything at the atomic level.
Leading to stronger materials, more efficient solar cells. Who knows what we'll discover next?
Exactly. It's a domino effect of discovery. And it all circles back to that same spirit of innovation, that drive to explore, to question, and to push the boundaries of what's possible.
And that drive has brought us a long way from the wheel to the microchip, from steam engines to vaccines. But we've also seen how important collaboration and even accidental discoveries have been.
Speaking of which, remember that story we started with Edison and the vacuum tube? Well, that seemingly accidental discovery was about to completely revolutionize how we manufacture things on a massive scale.
Now, how did we get from vacuum tubes to mass production? Okay, you've got my attention. Tell me more.
So as I was saying, Edison stumbles upon this thing with the vacuum tube totally changes electronics. But get this, it also connects to one of the biggest leaps in manufacturing, the assembly line.
Okay, now my mind is really blown. We were just talking about microscopic organisms and life-saving vaccines. How do we get from vacuum tubes to mass production?
Well, remember, the vacuum tube was this essential component in early electronics, right? But they were a pain to make, delicate, time-consuming. So naturally, people were looking for ways to speed up the process.
Makes sense. Time is money, as they say.
Exactly. And around the same time, the meatpacking industry, yeah, you heard that right, they were having their own little revolution in efficiency. They started using conveyor belts, dividing the work into specialized tasks.
Wait, are you saying that the assembly line, this icon of modern manufacturing, was inspired by butchering meat?
You got it. Henry Ford, the car guy, he sees this system in the meatpacking plants, and he's like, I can use that.
That's incredible. It's like finding inspiration in the most unexpected places.
Exactly. Ford adapts these ideas, creates the moving assembly line for his Model T cars. Instead of skilled workers spending hours assembling an entire car, you have each worker doing one specific task over and over as the car moves down the line.
And boom, cars become more affordable, more accessible, and mass production changes the world. Talk about a ripple effect.
It's mind-blowing when you think about how interconnected everything is. So to answer your question from earlier, how do we get from vacuum tubes to mass production? Well, it's a winding road paved with innovation, inspiration, and maybe even a little bit of, sausage.
That is wild. Okay, I have to admit, I'm starting to see those aha connections everywhere now. But where do we go from here? What does the future of invention look like?
That's the million-dollar question, isn't it?
Mm-hmm.
But based on the patterns we've seen, I think we can make some educated guesses. For one, I think we'll see even more blurring of lines between different fields.
Like how Ford got inspired by meatpacking.
Exactly. Imagine biologists teaming up with architects to design buildings that can heal themselves, just like living organisms. Or neuroscientists working with computer scientists to create AI that truly thinks like we do.
Okay, that's pretty mind-blowing. It's like the future of invention is about breaking down those walls we've built between disciplines.
Absolutely. And as we face bigger and more complex challenges, climate change, resource scarcity, you name it, we'll need all the brain power we can get. Speaking of which, don't underestimate nature's role in all of this. Biomimicry, looking to nature for design inspiration, that's only going to get bigger.
Right, we've already got airplanes inspired by birds, wind turbines inspired by whale fins. What's next?
Scientists are studying gecko feet to create super strong adhesives, looking at butterfly wings to develop new kinds of color-changing displays. The possibilities are endless.
It really makes you appreciate how much we still have to learn from the natural world.
Absolutely. And as we learn, I think we'll see a surge in inventions focused on sustainability and efficiency.
Renewable energy, cleaner transportation, things like that.
Exactly. We're already making progress, but the next few decades are going to be crucial. Imagine cities designed for self-sufficiency, powered by renewable energy, where technology helps us solve some of our biggest problems.
That's a future I can get behind. But it's not just about the technology itself, right? It's about how we use it.
You got it. The greatest inventions are often the ones that challenge our assumptions, push us out of our comfort zones.
So the future of invention isn't just about shiny new gadgets. It's about using our creativity and ingenuity to build a better world.
Couldn't have said it better myself.
What an amazing journey this has been. From the wheel to the microchip, from steam engines to vaccines, human ingenuity never ceases to amaze. But the story doesn't end here. What inventions await us in the years to come? What problems will they solve? How will they reshape our world and our place in it? Those are questions for another deep dive, another day. Until then, keep those curiosity gears turning.